In this video, I will give a quick overview on confidence intervals. So in inferential statistics, we study a sample to make inferences about a population. Suppose I wanted to estimate the average age a woman gets married, and I choose a random sample and I calculate the mean age. And I found that the sample mean age is 26. Okay, so this is from the sample. So that's why you see an X bar is equal to 26. This 26 is considered a point estimate of the mean mu. So what is a point estimate? A point estimate is a single number computed from sample data and is used to estimate a population parameter. Well, how much uncertainty is associated with a point estimate of a population parameter? In other words, how well does this single value represent the population? An interval estimate provides more information about a population characteristic than does a point estimate, and we call these interval estimates confidence intervals. So suppose we find that the mean age women get married lies between 23.5 and 28.5. As you can see, this is a range of numbers, or this is an interval estimate. We call the smallest number the lower confidence limit, and we call the higher number the upper confidence limit. So exactly how did we get this number? Well, we got this number because I took 26 and I added 2.5, and that's how I got the 28.5. I took 26 and I subtracted 2.5, and that's how I got 23.5. So I'm sure you're asking, well, where did this 2.5 come from? 2.5 is considered the margin of error. Okay? You see it written many different ways. I call it ME. You may see it written as E, but it's the margin of error. So basically, the confidence interval for a population mean lies between the sample mean, X bar, minus the margin of error, and the sample mean plus the margin of error. The margin of error is calculated based on a confidence level. The confidence level refers to the percent of confidence intervals from many samples that we expect to contain the true population parameter. And there are different confidence levels. We mostly see 90%, 95%, and 99%. So suppose that the true population mean is 26.5. From our sample, we calculated it to be 26. So, to give you a visual, if we select 100 samples of the same size and construct 100 confidence intervals at a 95% confidence level, we will expect 95 of these intervals to contain the population mean. So this is a visual. As you can see, the population mean is 26.5. And I calculated 100 different intervals, and they're all of the same size. And as you can see in the green ones, they all contain the population mean of 26.5 because the line goes through those intervals. However, 5 of those intervals do not. If you look at the one that I have in red, it says 21.526 to 25.446. That does not contain 26.5. Okay, so 5 of these confidence intervals do not contain the true population mean, and this is out of 100, whereas 95 of these will, and this is based off a 95% confidence level. So let's go back to our confidence level, and our interval, we already said it was between 23.5 and 28.5. And we did this at a 95% confidence level. The interpretation for this is we are 95% confident that the true population mean lies between 23.5 and 28.5. So this is how you interpret confidence intervals. So if we go back to our visual, one of these green intervals is my confidence interval of 23.5 and 28.5. It's one of the 100s of the confidence intervals that I generated. And so, since it contains the true population mean of 26.5, we can say that we're 95% confident that that true population mean falls in between those two values. That's the end of this lecture.